In this video I will be going over several examples which illustrate cost volume profit analysis. And I'm going to assume that you have already looked at the lecture notes for this section. So we usually just abbreviate it as CVP analysis. And of course the lecture notes here, they're on my website. I assume that you've looked through these. Now let's go ahead and start with the first problem, and we're going to take it from your ebook online, problem 520 right here. So the basics of CVP analysis. So that's the one we're going to be looking at first. Alright, so we have a company here. They produce memory enhancement kits for fax machines. Here's the contribution format income statement for the most recent month. And the first thing they want us to do is compute the company's contribution margin ratio and their break-even point, both in units and in dollars. So if we look at the lecture notes, we know that the contribution margin ratio is given by any of these formulas in this box. If you have V and P, you might as well just use this formula because it's equivalent to this one. It's still the contribution margin ratio. It's just if you have V and P, you can use this. This is like a shortcut. But we don't have V and P directly. We have P, which is $20 per unit, but we don't have variable expense per unit. We have total variable expenses, 189,000, and we know how many units they made, so we could get the variable expense per unit, V, by just taking 189,000 divided by 13,500 units. That would give us V, and we have P, and we can do 1 minus V over P. But since we don't have V directly, let's use this formula for the contribution margin ratio. We do have both of these things directly. So the contribution margin ratio is the dollars in contribution margin divided by the dollars in sales, or contribution margin in this case is 81,000. It's sales minus variable expenses. So we're 81,000 in the numerator, and we're divided by sales in the denominator, and sales is $270,000, and it looks like to be a contribution margin ratio of 0.3, I believe. 81 over 270 is 0.3. So for every dollar worth of goods we sell, 70 cents of it is used to cover variable expenses, and 30 cents of it is left over, left to contribute to covering the fixed expenses. Hence the word contribution margin. Now, they want the break-even point. Well, again, we can go to the lecture notes. We can see that the break-even point occurs by setting the profit equation equal to 0 and solve for Q. You'll see this is a Q that you will get. So profit as a function of Q, number of units sold, is equal to the price, which is $20. I'm going to suppress the dollars here. Profit is equal to sales, which is price times quantity, minus variable expense times quantity, minus the fixed expenses, and the fixed expenses they tell us are 90,000. V would be the total variable expenses, which they gave us are 189,000 right here, divided by the number of units sold, 13,500. Divided by the number of units produced, because we incur variable expenses to produce units. But we're assuming that the number of units sold are equal to the number of units produced here. So the variable expense per unit is 14, if you calculate that. So now we can put that right there. So we have a profit equation, 20Q minus 14Q minus 90,000. That's profit. and we want to break even. We're trying to find the number of units they must sell to break even. Break even means that profit would be 0. Solve for Q. So we have 6Q equals 90,000, or Q equals 15,000 units. So that's the break-even point. We're going to call it Q star. It's a special Q. It's not just any Q. It's the Q that makes you break even. We'll call it Q star. Now you can see that Q star can be given by the same formula that we looked in here in our lecture notes. F over P minus V. It's F. It's exactly what we did. It's F over P minus V. Or 90,000 over 6, which is exactly what we did. So part 2. The sales manager feels that an 8,000 increase in the monthly advertising budget, combined with an intensified effort by the sales staff, will result in a 70,000 increase in monthly sales. If they're right, what will be the effect on the company's monthly net operating income or loss? Here we use the change in profit equation from lecture notes. Right here. This equation tells us what will happen to profit. How much will profit change by, whether it will increase or decrease. This will tell us the dollar amount of the increase or decrease as a result of changing one or more of P, Q, V, and F. In this case, we're going to be changing F and we're also changing, so we're changing the fixed expenses because we're making advertising go up by 8,000. Advertising is a fixed expense. And we're also changing Q, the number of units, we're changing P times Q. Price times quantity is sales dollars, and price times quantity is going up by 70,000. So we can use this equation, P2Q2 minus V2Q2 minus P1Q1 minus V1Q1 minus F2 minus F1. That's just the change in profit equation from lecture notes right here. Now, the 2's represent the the 2's represent the price, or the new information, and the 1's represent the old. Excuse me. The 1's represent the old information. Now, what do we know? We know that advertising increased by 8,000. That means the new fixed expenses are equal to the old fixed expenses plus 8,000. And what else do we know? It said sales would go up by $70,000. That means the new sales revenue is equal to the old sales revenue plus 70,000. And using this, we can solve for the change in profit. P2Q2, what's that? Well, it's whatever the old sales revenue was plus 70,000. What's the old sales revenue before we make the change? Well, it's 270,000. So the new sales revenue after the change must be 340,000. So that's P2Q2 minus V2Q2. What are the new variable expenses? It didn't say that they were going to change the variable expenses. So the new variable expenses must be equal to the old variable expenses. What were the old variable expenses? 189,000. When I say old, I mean the variable expenses before the proposed change. So we do P2Q2 minus V2Q2 minus P1Q1. P1Q1, that's the old sales revenue. That was just 270,000. Minus the old variable expenses, 189,000. And then we subtract F2 minus F1. F2 is the old variable expenses plus 8,000 because we're increasing advertising by 8,000. I'm sorry, so F2 is the old fixed expenses plus 8,000. I think I said the word variable there. What are the old fixed expenses? $90,000. So the new fixed expenses are going to be 98,000. Subtract the old fixed expenses, which were 90,000. And if we do all this, this will tell us how profit will change. And if you do it, you will find that profit changes by $62,000, and it's a positive number, positive change. So that answer is number 2. Excuse me. I think I have to sneeze. Sneeze again. Hey, excuse me. I won't bother editing that stuff out of the video. Alright. So number 3, refer to the original data. The president is convinced that a 10% reduction in the selling price, combined with an increase of $35,000 in the monthly advertising budget, will double unit sales. What will the new contribution format income statement look like if these changes are adopted? Excuse me. Alright. We're going to do this in 2 parts. We're going to go ahead and we're going to answer this question in 2 ways. We're first going to calculate the change in profit as a result of these proposed changes, and then we're going to answer the question what they wanted us to answer, which was make a new contribution format income statement. So the change in profit would be, well, we know it's P2 Q2 minus V2 Q2 minus P1 Q1 minus V1 Q1 minus F2 minus F1. Now, what are the things that we're changing here? So it says refer to the original data. So everything is starting at the original data, which is right here. We don't care about what happened in number 2. So we're going back to the very beginning. Refer to the original data. They want to reduce the selling price by 10%. So that means that the new selling price, P2, is equal to the old selling price minus 10% of the old selling price, or it's the old selling price times 1 minus 0.1, or the old selling price times 0.9, or 0.9 times, and what was the old selling price? 20 bucks. And what is 90% of 20 bucks? I think you will find it is $18. So that's the new selling price. What else did we change? $35,000 increase in the monthly advertising budget. Well, that just means that the new fixed expenses are going to be the old fixed expenses plus $35,000, or the old fixed expenses were $90,000 plus $35,000. So the new fixed expenses will be what? $125. And then what else did they say? They say that if they do this, they think that that will double the unit sales. So that just means that whatever they sold before the proposed change, oops, come on, whatever they sold before the proposed change is going to be equal to half of whatever they sell after the proposed change, because they think that unit sales will double. So that just means that Q2 will equal 2 times Q1. New unit sales is twice old unit sales. And if old unit sales were 13,500, then new unit sales would be 27,000. So now that we have this, we can plug into our change in profit equation. P2 is 18 times Q2, 27,000, minus V2 times Q2. V2 new variable expense per unit, that's just the same as old variable expense per unit. We didn't change that, right? V2 equals V1. We didn't say anything about changing that. So the old variable expense per unit we found earlier was $14 per unit. And V2 is 14, and Q2 then is 27,000. And then we're going to subtract P1 Q1, which we know what P1 Q1 was. It was 20 times Q1, and Q1 was 13,500. And then minus V1 Q1, 14 times 13,500. And then we're going to subtract F2, 125,000, minus F1 minus 90,000. And that'll give us our change in profit. And you will find that the change in profit equals negative $8,000. So if we do this, our profit's going to go down by $8,000. Now let's see this with a contribution format income statement. Our new contribution format income statement would look like this. Sales would be $18 per unit times 27,000 units, or if you calculate that, $486,000. Variable expenses would be the variable expense per unit 14 times the units 27,000, or $378,000. And that means our contribution margin would be the difference between these two, which is $108,000. Then subtract our fixed expenses, and our fixed expenses now would be $125,000, and that gives us a profit of $17,000 negative, it looks like. Or the way to write that in an accounting sense is just put parentheses around it. And you can quickly see then that $17,000 negative profit after doing this change is $8,000 less than the $9,000 negative profit that we were making before the proposed change. So profit did indeed go down by $8,000. We were originally losing $9,000, now we're losing $17,000. So this is correct. But what they wanted was this new contribution format income statement. And then number 4. Let's see, what does it ask for here? It says, refer to the original data. The company's advertising agency thinks that a new package would help sales. If they can just package it in a different package, then they're going to sell more units. Okay. The new package being proposed would increase packaging costs by 60 cents per unit. All that means is that variable cost per unit is going up by 60 cents. Assuming no other changes, how many units would have to be sold each month to earn a profit of $4,500? Alright, so we're going back to the original data. We know our profit is going to be equal to 20 times Q minus our variable expense per unit, which is now 14.6 times Q, because it was 14, but if we do a new package for each unit, it increases the per unit cost by 60 cents. So that's just an increase to the variable cost per unit. So minus 14.6 times Q minus our original fixed expenses. And they said if we do that, we expect to earn a profit of $4,500. How many units do we need to sell to earn a profit of $4,500 is the question. So we just solve for Q. So 5.4 Q equals 94,500. So Q equals 94,500 divided by $5.40. Q equals, we would need to sell 17,500 units if we want to earn $4,500 of profit. If we make this, or if we have a new package that we put each unit in and sell it to the customer. So we'd have to increase our sales by 4,000 from what it is currently. So I guess the question is, that's the answer to the question, but a better question is, does the increase in variable cost per unit of 60 cents, putting it in a new package that makes it more attractive to the customer, can that lead you to selling 4,000 more units than you're currently selling? Because we're currently selling 13,500. So we got to sell 4,000 more if we want to achieve this target profit. All right, number 5, refer to the original data. By automating, the company could slash its variable expenses in half. However, fixed costs would increase by $118,000 per month. Compute the new CM ratio and break-even point, both in units and in dollars. So we have part A. CM ratio, let's use the formula 1 minus V over P now. Right? It's the same thing as what we were doing earlier. But it is, earlier we were using this formula for the contribution margin ratio. But let's use this one now. So, variable expenses are going to be slashed in half. That means that the variable expense per unit was going to be slashed in half, right? So that means that V now will equal what it was previously divided by 2, or $7 per unit. And does it say anything else is going to happen? Fixed costs would increase by $118,000 per month. Fixed costs don't change the contribution margin ratio. Contribution margin ratio is not a function of fixed cost. So all we have to do is calculate 1 minus 7 over 20. And our contribution margin ratio would be 0.65. Now B, no, sorry, still at A. Break-even point. Our profit would be 20Q minus 7Q minus fixed expenses, and fixed expenses would be 118,000 higher than they currently are. So they would go from 90,000 all the way up to 208,000. Set equal to 0. Solve for Q. 13Q equals 208,000. So Q, we'll call it Q star, equals 208,000 over 13. And I believe that's 16,000 units. We would have to sell 16,000 units just to break even if we cut our variable expense in half per unit by going to an automated manufacturing process. In other words, we use more robots versus humans, less human labor. But however, with that, our fixed expenses are going to go up by 118,000, right? And so we'd have to sell, it looks like 16,000 units just to break even. Make sure that's right. Yeah, that's right. Part B. Oh no, don't delete the page. Append the page. Part B. Sorry, am I read to part B yet? Part B is assume that the company expects to sell 20,000 units next month. Prepare 2 contribution format income statements. One assuming that operations are not automated, and one assuming that they are. All right, let's do that. Not automated. Automated. Sales. Variable expenses. Contribution margin. Fixed expenses. Profit. So we're just going to copy this. We're going to prepare 2 contribution format income statements, both under an automated and a non-automated scenario. So either way, our sales is the same. It said we were going to sell 20,000 units, and we're selling each unit for $20. So sales is 400,000 no matter which scenario. It's just our costs change if we're automated versus non-automated. If we're not automated, our variable expense per unit is $14 per unit times 20,000 units equals 280,000. So our contribution margin ratio is 120. Our fixed expenses, if we're not automated, are only 90,000, and that means our profit is 30,000. If we're automated, our variable expense per unit is now only $7 per unit, and we produce and sell 20,000 units. So that's only 140,000. Contribution margin ratio is 260,000. our contribution margin is 260,000. The ratio is that divided by the sales. So our contribution margin is 260,000, and then our fixed expenses now, instead of being 90, they went up by 118 because of the automated procedure. So now they're 208. Nevertheless, our profit is 52,000. It's 22,000 higher than our profit if we're not automated. And so the question is, C, would you recommend that the company automate its operations? Yes, because you always answer this question yes if change in profit is bigger than 0. And if it's not, if it's less than 0, then you say no. And if it's equal to 0, then you're indifferent between saying yes or no. Now we could verify that the change in profit is bigger than 0 by using our change in profit equation that we've been doing from lecture notes that we were doing earlier, right? We could use this equation, we could figure it out. We would find that the change in profit is exactly $22,000 from not automated to automated. Profit goes up by 22,000. As you can see, 52 minus 30. We would find that this is 22,000 if we use that equation. I won't go through that since I've already done it in a previous problem. Alright, let's go on to the next problem. Now for this one, we're going to go to a different book which you don't have access to, but it's a different online book. And we're going to look at exercise, if I can find it. Or maybe it's a problem. No, it's exercise 16.24. Activity-based costing, or cost volume profit analysis with activity-based costing. CVP with ABC. This comes from a different book. So you might want to copy this problem down on a sheet of paper. That way you have the problem, because you won't have any way to reference what this. You'll see the answers in my in this video, but you won't have a way to reference the problem if you're going back trying to study it. So Busy Bee Baking Company produces a variety of breads. The average price of a loaf of bread is $1. Costs are as follows. So the V, the unit variable cost per loaf of bread, is 65 cents. And then they have two activities that drive costs. We have setups. It costs $300 for one setup, and maintenance hours, $15 for one maintenance hour. 150 setups are done during the period, whether it's year, month, day, whatever this period is. I assume it's probably year. And then maintenance hours, 2,500. And then the total fixed costs, 140,000 if we use a traditional contribution format approach of thinking about costs. And if we think about costs using ABC, then the fixed costs are 57,500. And you will recall from our discussion on when we were discussing activity-based costing that the fixed costs will be lower under ABC than they will under traditional, because ABC traces more costs to actual products and therefore calls or labels less amount of the total cost as fixed. So that makes sense. Now, number 1, compute the break-even point in units using conventional analysis. Well, if we use conventional analysis, we ignore the activities, and our break-even point computation is done just as we've been doing it all along. Take our profit equation, we set it equal to 0, and solve for Q. Right? So P in this case is $1 each loaf. First of all, what are the units of the output? The units are loaves of bread. So one loaf is $1. So P is at 1. So 1 times Q minus, what are the variable expenses per loaf of bread? Well, using the traditional analysis, we ignore the activity costs. We just look at the 65 cents per loaf. And then we subtract the fixed costs, which under the traditional method were 140,000. So there's our profit equation. We set it equal to 0, solve for Q. We're going to find that if we take 1Q minus 0.65Q, that's 0.35Q, equals 140,000. and Q, we'll call it Q star, equals 140,000 over 0.35. Which is 400,000 units, or 400,000, we'll just call it units, but the units here are loaves of bread. If we sell 400,000 loaves of bread, we'll break even, using the traditional analysis. Now question 2 is, using ABC costing, calculate the break-even point in units. Well, under ABC, our profit is a function not only of number of units sold, but also of number of setups. In this case, we'll let S equal the number of setups, and then also a function of, in this case, number of machine hours, the activities. All right, so S equals number of setups, and MH equals number of machine hours. So our profit then is going to be sales, which is price times quantity, minus our variable expenses, 0.65 times Q, minus, so these are the expenses related just to number of units sold. Then we have our expenses related to setting up, and we have our expenses related to machine hours. So the expenses related to setting up would be the variable cost per unit of setting up, which is, I believe each setup was $300, times the number of setups, minus, and the expenses related to, what was the second activity? Maintenance hours would be the variable cost per maintenance hour, times number of maintenance hours. And then finally we subtract the last expenses, would be the fixed expenses, which under ABC we said would be 57,500 right here. So this is our profit equation if we use ABC, and this is our profit equation if we use conventional analysis. Now we take the profit equation under ABC and we can find the break-even point. We can find Q star. So 1Q minus 0.65Q is just 0.35Q. Minus 300S, but we know what S is. The number of setups is 150. Minus 15 times machine hours, but we know what the machine hours are. They're 2,500 every year. Minus the fixed cost, 57,500, equals 0. And that means that 0.35Q equals, and then we put everything on the other side. 57,500 plus 300 times 150 plus 15 times 2,500 is 140,000. And coincidentally, it just turns out that way, that the break-even point under ABC is exactly the same as the break-even point using conventional analysis in this particular problem. You might wonder, how do I get the number of setups and the number of maintenance hours? Well, they were given to us right here. Alright? And we're solving for Q, the number of units that we must produce to break even. We don't have to solve for S or MH. They're given to us. Alright, and then part 3. Part 3 is you repeat part 2, but using a different assumption. Instead, you suppose that you can reduce the setup costs by $100 per setup, and you could, so the new the new cost per setup is now $200. It was $300, but we reduced it by 100, so it's $200 per setup. And also suppose you can reduce the number of maintenance hours needed to 1,000. So instead of needing 2,500 maintenance hours, we need only 1,000. Now how many units must be sold to break even? So our profit equation now is 1Q minus 0.65Q minus, instead of 300 times S, we reduced the cost per setup by $100, so now it's 200 times S. And S is still 150 setups. Minus, and then the machine hour the maintenance hour cost per hour was 15, but instead of needing 2,500 maintenance hours, now we only need 1,000 instead. Then minus the fixed expenses. Didn't say anything about those changing. And we set our profit equal to 0 and solve for Q. So yeah, 0.35 Q equals, and then we put everything else on the other side. 200 times 150 plus 15,000 plus 57,500 is 102,500. Solve for Q, and we find that Q star, the break-even point, we need to sell at least 292,857 units to break even in this scenario. So what's interesting is with ABC, we realize if we analyze our cost using ABC, then we take note of these costs for setups and maintenance hours, and then we realize, hey, if we can reduce our setup cost by $100 and we don't need as many maintenance hours, we see that our we don't have to produce as many units just to break even as we did before. So that's one of the insights that you get from using ABC, activity-based costing. And then doing that first, and then analyzing your cost, doing the cost volume profit analysis using the ABC and activity-based costing. So that concludes that problem. Let me make sure that that's right. 102,500 divided by 0.35, 292,857, yeah.